All right, so we're going to continue with 27. In this case, we have a club with 17 members. We want to choose 3 officers: president, vice president, secretary, treasurer. That's going to be one part. Each office is to be held by one person, and no person will have more than one. How many ways could we choose those people? So I'm going to start this one off doing it with blanks. So we have president, vice president, and secretary treasurer. Since we have 17 members, we could choose the president one of 17 ways. All right, now that we've chosen somebody for president, we only have 16 people left. And then, of course, once we've done that, we only have 15 left for the secretary treasurer. So I could multiply these across, and I would get 48. Now, since this is 11.2, surely we could use permutations here. And we can, and I'll show you how we'll do that. Since we have a total of 17, I'm going to do is say we can use the formula. The formula NPR, in this case, 17 is our N. And our R, since we're choosing 3 things, that's our R. So 17 NPR 3 gives me 48. Okay, number 30. We're at a concert. We got a concert. There's 12 bands that have volunteered to perform. There's only enough time for 6 of those bands to perform. So the question is, how many lineups are possible? Well, this is very similar to 27, but I just wanted to do this one anyway. I could use blanks. On many of these, I could do blanks and get the right answer. Now the question is, how many blanks would I use? Since we have 12 bands, but only 6 are performing, it means we'll use 6 of the blanks. Okay. So who could go first, second, third, fourth, fifth, and sixth? And there's no restrictions here. No one band has to go last. So there are 12 bands, so 12 could go first, and then 11 could go second, and so on. I can only go down to this position: 12, 11, 10, 9, 8, 7. I'm going to type all of those in. 12 times 11 times 10 times 9 times 8 times 7. It's a rather large number if I type those in. I'll do it down here: 6, 6, 5, 2, 8, 0. And I want to show you I could do the formula as well. So we got 12 bands. We're going to choose 6. I better be careful. I'm not choose 6. 12 pieces. And I had to catch myself because I said choose. That's actually 11.3, where we'll use that language. So 12 NPR 6, and again I get that number 66528. All right, then we get to number 32. Well, while we've talked about permutations, I gotta say one more thing before we're able to do 32, 33, 34. Okay, so let me explain that. So, in order to figure out all the distinct permutations from a word, let me do an example first. I gotta kind of back up. So, how to find all of the unique permutations of a word or string of digits, because that's a question as well. So I'm going to use the word Mississippi because it's got plenty of repeating letters. So I'm going to write out, if I can spell it correctly, Mississii. Okay. Now, what I actually want to do is I'm going to highlight one of these. I'm going to highlight one of these S's. And I have a point for that. And so that one's been highlighted. Maybe I can make it a little larger. So my point here is this is an arrangement of the letters in the word Mississippi. Is this unique? All right, so here's what I mean. So I'm just going to switch this S and this S. M-I-S-S-I-S-I. Now, it's the same word. I moved this S to there. So it's in the third spot. It's still the same word. It's still the same arrangement because these letters are all the same. All these S's are the same S. All the I's are the same I. So this is not unique. I'm going to write it in red. So if we're asked this question, we have to deal with all the repeats. Okay? So we must deal with repeating letters or digits or things. By dividing. Here's what I need. In order to work this problem, I will count up all of the letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters in this word. Okay. So 11 factorial. Then I have to divide by anything that repeats, the factorial. So here's what I mean. I'm going to do this. I'm going to say total number of letters is 11. That's where that comes from. All right. M does not repeat, but I does. 1, 2, 3, 4 I's. So the number of I's is 4. So I have to divide by 4 factorial. Okay, so that is right there. And I do that with any number, anything that repeats. The S's repeat. 1, 2, 3, 4. 1, 2, 4. So there's another 4 factorial. In fact, I could write number of S's. And that also is this number here. Do I have anything else that repeats? Got two p's. Okay. So number of p's is 2. So I got to put a 2 factorial. Okay, so it's a little messy. I should have been a little clearer there, but this is what I need to do. Okay, but I got to be careful when I type this in. I can type it in all at once, but you got to use parentheses. I'll show you what I mean. 11 11 factorial divided by, I'm going to put some parentheses to tell it to do the bottom. 4 factorial times 4 factorial times 2 factorial. Again, 34650. The 11 factorial divided by, and I put parentheses around everything in the denominator. Okay, so since we went through that example, I will skip number 32. I'll go ahead and do number 33, 34, and 35. Number 33. We got number. We got to figure out how many ways can these digits be arranged. All right. Total number of digits. 1, 2, 3, 4, 5, 6, 7. That's going to go on top. Now, what repeats? The 7 doesn't repeat. Let's see. It's a little fuzzy there. The 7 does not repeat. We got 2 4s, so number of 4s is 2. So 2 factorial. We got 1, 2, 3, 4 zeros. Okay. Again, you got to be careful typing this in. You could do the top and then do each of those numbers. I found students typically prefer, they can type stuff in all at once. So 7 factorial divided by, now we've got 2 things in the denominator. I'm going to do 2 factorial. I put my parentheses. Got a 4 factorial. Okay. And I got 105. So 105 ways. And then number 34, it actually is the same question. I mean, it's the same type of question, but it's kind of different. So a signal can be formed by running different colored flags up a pole, one above the other. Find the number of different signals consisting of 7 flags that can be made up of 3 white flags, 2 red flags, and 2 blue flags. Okay. So we have 7 total flags. It says we have 3 white flags, 2 red flags, and 2 blue flags. So this is that same question. The total number is going to go on top. 7 factorial. And then all of these repeating things will go on bottom. So 3 white. I gotta put a factorial. 2 reds. Gotta put a factorial. And then 2 blue. And so we'll work that out. So 7 PRB factorial. Now I have to put my parentheses or something's going to go wrong. 3 factorial, which of course is 6, and 2 factorial is 2. So you could do that probably in your head. 6 times 4 is 24. But if you want to type it in directly, you can. And I got 210. All right. And then lastly, number 35. It's actually pretty easy. Okay. 35. 7 men and 7 women line up at a checkout counter. And the question is, in how many ways can they line up if the first person is a man and then it alternates, man, woman, man, woman, man, woman. So, I might look at this with some points. That's 7 men and 7 women. So let's do, let's guess that's a total of 14. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, I'm going to come back over here because I ran out of space on my paper. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The first person in line is a man. I'll color coordinate this red and black. Second is a woman. Next is a man and a woman. In fact, I'll go ahead and label the rest of the women. Okay, so that's what it kind of looks like. And so in the first position, we got a total of 7 men. So I have 7. Now, instead of going 7, 6, 5, 4, 3, 2, 1, well, this is the first woman I get to. We still have a total of 7 women. Now, at this point, I have 1 less man, so 6, and I also have 1 less woman. So I kind of have 7, 7, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1. In fact, here's what's going on. We got 7, 6, 5, 4, 3, 2, 1. That, all of these long closer. That is all 7, 6, 5, 4, 3, 2, 1. That is just 7 factorial. And in fact, here, 7, 6, 5, 4, 3, 2, 1. That is also 7 factorial. So in this problem, I have 7 factorial times 7 factorial. So I could type this in, 7 factorial times 7 factorial. Get a really, really, really big number, but that's fine. 25,40160. So 25,401,600. That is